Chapter 8, Pythagorean Theorem, and Converse, 8.1. Chapter 8 is going to be great. I love Chapter 8. Okay? Just putting it out there. First, we have this thing called Pythagorean Theorem. I'm sure you've heard of it. It's if we have a right triangle, this right here is true. Again, math is all about patterns, and this pattern is going to be the same in any right triangle. Now, the biggest thing in this right triangle is labeling the C. Because in a right triangle, the length across from your right angle is always going to be your hypotenuse. That's very important. This is going to be the most important line that you will ever label in a right triangle. Now, when you have the hypotenuse, so looking at this triangle right here, you can figure out the length. Now, when we talk about length, we want the length in simplest radical form. It does not matter which one of these side lengths I have as A or B, because the fact that in this equation, the C is the most important. So C is what I'm looking for, the hypotenuse. So I have 21 squared plus 20 squared is going to be equal to C squared. Now, 21 squared. So this part you can do in your calculator. 21 squared is 441. And 20 squared is 400. And that's equal to C squared. If I add those two up now, 841 is equal to C squared. Now, a couple of things. To get rid of something squared, I can take the square root, because that's the opposite. So the square root of 841 would give me my answer. Now remember, whenever you take a square root of something, this number could be positive, negative. However, we're talking about real world situations here. So when we have this 800, the square root of 841 is equal to C, this case will always be positive. Even though there are still two answers here, this is going to be positive. Now, if I wanted my answer in simplest radical form, this is all I can do, because this is actually a prime number. I cannot divide this by anything. If I wanted it to be to the nearest 10th or 100th, I go square root. So my square root button is this right here. So I have to push the second, then square root, then 841. And I would get that this is equal, oh, that's a perfect square. This is equal to 29. So C, I was wrong when I said that it was a perfect prime number, so C is equal to 29. Again, and we're only doing the positive number because of the fact that this is a length and it cannot be negative. So now I want you to pause the video and try to do this second one by yourself. So you should have gotten 8 squared plus 15 squared equals C squared. Now here I can take the square root of this, and 289 is also a perfect square, so 17 is equal to C. Again, we're only choosing the positive number because of the fact that this is a length. So now, what if I have to figure out what a leg is? In this one, I'm looking for a simplest radical form. Again, it does not matter which one's A and B, it's the C that's most important. So when I write up this equation, 8 squared plus x squared will be equal to 20 squared. So this becomes 64 plus x squared will be equal to 400. If I subtract my 64 off, you get that x squared is equal to 336. So again, you want to take the square root of both sides. This one is not a perfect square, so x would be equal to the square root of 336. Now, this is why we reviewed our simplifying radicals. So if I do my factor tree here, I'm looking for my groups of 2. So here's a group of 2, and here's a group of 2. So this is going to be equal to this 2 can come out, multiplied by this 2 that's already out there. This 21 stays inside the root. So my final answer would be 4 square root 21. So that is what x is equal to. I want you to pause the video and try to do B by yourself right now. So you should have had 10 squared plus x squared equals 16 squared. You subtract off that 100. Now we're looking for our groups of 2. So here's a group of 2. There's no group of 2 there, so only 1, 2 comes out. So my x will be equal to 1, 2 on the outside. both this 3 and 13 stay inside of the root. Those get multiplied together, so it's 2 square root of 39. So problem 3, if there's not a picture given to you, you need to draw a picture. In this whole chapter and everything with dealing with geometry, you should always draw a picture if a picture is not given to you. So it's saying that you have a 12-foot ladder leaning against the house. So when I draw this picture, this right here would be my ladder. So that says it was 12 feet. Leaning against the house says the base of the ladder is 4 feet from the house. So here's the house, here's the base of the ladder, so this is 4 feet. Now, whenever you draw something like this naturally, when you're talking about a height of something, it creates a 90-degree angle. It's asking how high is that ladder above the ground. Now this problem is like this problem, except it's asking it for the nearest tenth of a foot. So now I want you to pause the video and try to do this problem by yourself. So you should have got 4 squared plus x squared equals 12 squared. So I'm going to subtract that 16 off of the 144 to get the x squared by itself. Taking the square root of this, it says to the nearest tenth. So that's 1 decimal spot. So you should have gotten 11.3. Now my units here are in feet. So it is 11.3 feet above the ground. I want you to try to pause and do B right now by yourself. Draw the picture and try to solve all the way to the end. So your picture should look something like this. My height is 15 feet, and the way from the telephone pole is 4 feet. It's asking how long should the wire be. So it looks something like this. Now, because of the fact it doesn't tell me how I should round this to, you should always round at least the nearest tenth. So right now, my wire should be 15.5 because that's the square root of 241. And again, my units here are feet. So in a right triangle, this is always true. Whenever we have a right triangle, my hypotenuse is going to be squared is equal to my other two lengths added together. Now there's another thing that we can do here is we can look to see if this is a right triangle. So my highest length, so my 85 is my longest length here. No matter what, that's my hypotenuse. I can check to see if this is a right triangle because I want to look to see is 85 squared, will that be equal to 84 squared plus 13 squared? And then we compare the two lengths. So 85 squared is 7,225 and 84 squared plus 13 squared is 7,225. So is this a right triangle? Yes, this is a right triangle because of the fact that these two are congruent. Pause the video and try to see if this one is a right triangle. So when I look at these two, this is not a right triangle. However, we can still use this information to figure out what type of triangle this is. Because when I have my largest length, that will always be my C, okay? So now let's say in this case scenario, if your C value by itself squared is larger than the other two, that means this will create an obtuse triangle, meaning that this angle C is greater than 180. So greater than 90. That angle C is greater than 90. That's what obtuse means. If in this case, like this case up here, this right here, my a squared plus b squared is larger, this created a acute angle, meaning all these angles are less than 90 degrees. Every angle there is less than 90 degrees. So right now, I want you to decide for these next two problems. So looking at this, I'll help you label the A, B, and C. So this is A, B, and C. I want you to tell me, is this acute, obtuse, or right? Do A and B. So for this first one, so my C by itself, that one is larger, so this triangle is obtuse. For the second one, my A and B added together, that sum is larger than my C by itself, so this would be acute. Just a cute little guy. And there you have it. Chapter 8.1 done. Have a great, grand, wonderful day.